So you asked for a quick review video, and so I'm going to do this for you. I'm going to talk a little fast, so feel free to, go back, play it again, pause it, whatever you need to do. The first topic that you're going to be tested on is matter, and you have to know the difference between solid, liquid, and gas. You need to remember that solid has the lowest energy, that the molecules are pretty packed together, which makes it the most dense typically. They do vibrate. They just don't flow past one another. And you cannot compress it. If I changed the container that the solid was in, the shape and the volume would not change. For a liquid, the molecules are a little bit further apart. They move a little bit more by flowing past one another. You cannot compress it. The volume would not change, but the shape would change. And it has a little bit more energy than a solid, but not as much as a gas. In a gas, the molecules are super far apart. They're moving very fast. You can compress it. And you can compress it because of all this empty space that's in between the molecules. You can, push the molecules closer together and there's not as much empty space. They have the highest energy. The volume and the shape would change if you change the container. You also need to know your 6 phase changes. You have condensing, which is when you go from a gas to a liquid. You could have evaporating, which is the opposite, liquid to a gas. You can have melting, solid to liquid, freezing, liquid to solid. And then the 2 that were new for you were sublimation, which is a solid to a gas. So it skips that liquid phase. This was your dry ice. And then your deposition would be the opposite of a gas to a solid. The example I used for that was snow. That's basically it for solid, liquid, gas. Make sure you look over your notes and everything else that you need to kind of review. Make sure that you're not just using this one video as your review. Make sure you're still doing everything on your part as well. Okay, so the next part of matter was element, compound, and mixture. An element is when you have one type of atom. So you might see an element on a particular drawing that looks like that, or you could have the same element bonded to itself. Remember, there was 2 names that you could have used for this, a diatomic element. I even went in and listed the 7 diatomics off the periodic table, but you don't have to have that memorized yet. They can also be called a molecular element. Molecular because there's more than one, but it's still an element. Okay, a compound is when you have 2 or more types chemically bonded. If it's chemically bonded, the only way you can separate them is chemically. We show that bond by having them touch. That's a compound. No special names for that. Your mixture, there you could be 2 types. On a particulate diagram, if everything kind of mixed, like it's all spread out and mixed like that, there's no clear definition of 2 layers. This is your homogeneous mixture. And it's a mixture because I have 2 different ones. I have some that are filled in and some that are not, but they're not touching. Okay, so this is when I have 2 or more pure substances. These are pure substances. So I have 2 or more pure substances mixed together. It's physically mixed, not chemically bonded, which means I can separate it by physical means, and I'll go over those in a second. And then you have heterogeneous. Heterogeneous, you would see a clear definition. Let me actually make 2 layers of that, of layers. Okay, so in this problem right here, you can kind of see how there's a layer started, and maybe this is the water and this is the oil because oil floats. This is a heterogeneous because you see layers. Okay, it looks different. A synonym for this is solution. A synonym for this one is suspension. Because in a suspension, something is suspended above something else, so you create those layers. An example of this would be salt water, sugar water, anything that dissolves, really. Over here, it could be sand and water. It could be rocks and water. It could be salad dressing. All of those are types of examples of heterogeneous. Now, if we did need to separate a mixture, we would separate by physical means. And there was several that we talked about. We talked about just evaporating. If we have an example of salt water, we could evaporate the water off and leave that crystallized salt behind that's in the solid form. We could also decant something. Now, decanting would only work if the particles were large, like rocks in water or sands in water. You would just kind of literally hold the stuff behind and try to pour the water out off of it. Then you have filtering. This is one you did several times in class. This only works for large particles like sand. The salt would pass right on through, but it would hold the sand up in that filter. You have distillation, which is usually used for two liquids, although we could use it for salt water, but it's when whatever we're evaporating off, we want to keep. So you might have a beaker with a tube that comes off of it and it attached to another beaker over here. You would have, let's just say salt water. Water boils at 100, so you could heat it up. The water evaporates up in here. There's another mechanism that cools it off, condenses it back, and the water drips over here. And it would leave salt behind over here. The purpose of this would be to keep the water. If you were evaporating and didn't care to keep the water, then that's good. That works for you. But distillation is when whatever we're removing, we want to keep both parts of it. And then there was chromatography. Chromatography is used with a solvent, which is just a liquid that it's in, and a special piece of paper. And then the mixture can be separated based on how much it likes the solvent. We'll get more into this later. This is your part 1 video.